All right, everybody. So our last example here of exponential functions is compound interest. So this is the idea of interest. It's not simple. It's not basically, you get a sum off of what you deposit initially. Compound interest is like you deposit a bit of money in, you get some interest on it, and then the next month they give you interest on the total of what's in there. So not your starting point, but everything that's in there, including the new interest that's in there. And it's basically kind of like a snowball. Is you start off with a small amount, you get some interest on it, and then the next time you get even more interest because it's on a bigger amount, and then just keeps growing and growing and growing and growing. So definitely a good way to look at interest, especially if you're the one that is doing some depositing, and you can make some money off of that. So the formula for this, a little bit complicated, a few things to plug in. P, in this case, is your starting point. That's going to be the principal, or what you put in to start the account. And then the rest of the formula, filling in some blanks here. So 1 plus R is your interest rate over N. N is the number of times per year that it's compounded. So for example, if you have monthly compounded interest, that would be 12. And then there's another N up here. Again, the same value. If it's monthly, there's another 12 up there. And then up top is T, and that's the number of years that you have this money in the account. So I'll spell this out more clearly. T equals your years. N equals the number of times per year that the interest is compounded. The R is the interest rate. And P is your starting point, the money you put in to start. So let's say you have $1,000, so that's your P. The interest rate is 5%, and the number of times per year you have monthly interest. And you invest this $1,000 before going to college or trade school, so you're thinking maybe you'll just leave it in there for 4 years and see what it is when you leave school. So it'll be like a graduation gift to yourself, the amount of interest. So let's plug this in. So the amount of money you get is 1,000, 1 plus interest rate of 0.05 over 12, because you're doing it monthly, so that's 12 times. And then 12, number of years is 4. So we'll plug each of these things in and evaluate it basically one step at a time. So we'll do 0.05 divided by 12 first and add it to 1. So inside here we have like 1.0042 to the 12 times 4 is the 48th power. Again, don't want to round here, so try to do this all in one step if you can. So we end up with 1,000 times 1.22 rounded. And again, I'm not rounding this because I'm keeping it all in the calculator in one line here. So basically using that answer command to basically make sure we're not rounding and losing some money. Multiply it all by 1,000, and we're left with $1,220.90. So if you think about it, not too bad. A 5% interest rate is, decent. Over 4 years, you take $1,000 and it grows by, a little bit over 20% total. Not a bad investment, honestly. So again, that is a lot of time to not use that money, though. So if you could make more money somewhere else with that $1,000, but if you were to use it on like video games or going out to eat, maybe it is better to grow it by a few $100. But that's kind of the idea. So this is a good way to basically evaluate investments. If you do something like a CD, which means that you put money and you agree to not take it out in exchange for a higher interest rate, you can see that you might grow a little bit. So by playing with a couple of things that you have control over in terms of which one you choose, so you could choose a bank with a higher rate. You could choose a bank that compounds more frequently. Maybe instead of monthly, you'd rather it be weekly. Just depending on what options are out there, you might be able to find a way to maximize your money. But the biggest thing for this is taking a look at this formula and all of the pieces that we use to plug in. So a bit of reading comprehension is needed for this in terms of interpreting what it is. So if it's quarterly, that means 4 times a year. Monthly is 12 times a year. It might be useful to make a chart. So how many times per year? So yearly means 1 time per year. Monthly means 12 times per year. Quarterly would be 4 times per year because there are 4 quarters in a year. And there's a bunch of different ways. I would say when in doubt, either ask or try to research it, look it up and see if you can find it. But yearly, monthly, and quarterly are basically the most common things that you're going to find when you're plugging in for that n value in your compound interest formula. So a few examples, I'm going to have to answer those based off of these things. Again, focus on plugging in and clearly defining what each of those are in terms of P, N, R, and T. And again, use that formula, carefully plug it in, use some PEMDAS. And if you do that, you're definitely going to be successful in determining how much money can you make with this compound interest formula. Or the sad side of it might be, how much debt do you owe if it's compounded interest for debt that you have to pay the bank on a loan. All right, everybody, thanks so much for watching. I will see you soon, as always. Reach out with questions, email, message, any of those things. We are here to help.